Hello all, welcome back to AK Apt Logics. In the previous class, we have discussed about the NOT gate and also NAND gate. We have implemented those particular NOT gate and NAND gate in all levels of abstraction. Okay, we have also seen the outputs in the form of TCL console, and also we have seen the output in the form of waveforms. Okay, today in this class, we are going to discuss about the AND gate. Okay, we are going to discuss about AND gate, that too in gate level model. Okay, I am going to discuss about AND gate in gate level model. In gate level modeling. Okay, so every C program, okay, I think you have an idea about the EDA Playground. If you are not going to have an idea about EDA Playground, we are going to write the design code of our logic in this particular right side portion, and we are going to write the test bench in the left side portion. Okay, now I am going to write the design code for the AND gate in gate level model. So Verilog program is going to start with the module and end module. It is going to end with the end module. Okay, every Verilog design code we are going to write in between these two. Okay, one is module and then end module. After module, you should give the module name. Okay, I'm going to give the module name as AND gate. Okay, you shouldn't use the keywords like AND. So for example, if I am going to use the AND, you can see it is got highlighted with the violet color. Okay, you shouldn't use this particular name. Why? Because it is a primitive. Okay, after giving the module name, you need to give the port list. For that, you need to open the parenthesis. Okay, and then you need to list the what are the inputs and outputs for your particular AND gate. In this case, we are going to write the code for the two input AND gate, right? The AND gate looks like this. Okay, the AND gate will looks like this, right? Sorry, don't worry. The AND gate will looks like this. It is going to have two inputs. Let us assume those two inputs as A and B, and also let us assume the output as Y. Okay, it is going to have two inputs and one output. Okay, so that I am going to declare them as input A comma B, and by default this particular inputs will be treated as Y data type. Okay, by default inputs and outputs will be treated as Y data type, and also we need to require that only. Okay, only in the behavioral modeling we should declare output as reg data type. Okay, otherwise you just leave that like this, declaring like this input A comma B, and we are going to have one output, right? Output Y. Okay, you have started the parenthesis, close it, and then semicolon. Don't forget to put the semicolon. Okay, now next, after semicolon till end module, we are going to write our logic based on our levels of abstraction. The level of abstraction that we have uh, going to do is the gate level model, right? Well, now we are going to see about the gate level model, so that I am going to write the code in gate level model. In gate level model, to write the code for the AND gate, you are going to have some primitives, predefined primitives. In this case, our primitive for AND gate is AND. Okay, followed by instance name. Instance name is nothing but just a name for giving name to give that particular AND gate. Okay, I am going to give that AND gate as A naught. Okay, and then open the parenthesis, close the parenthesis, semicolon. In this parenthesis, you need to give the parameters. Okay, first parameter must be output. Okay, for any primitive of gate, the first parameter must be output followed by inputs. Okay, in this case, for our design, output will be Y, and then inputs will be A comma B, right? Since we have taken only two inputs, I have mentioned two inputs only. If you are having n number of inputs, then you can mention like this as you wish. Okay, followed by the comma in between them. Okay, so first parameter I have mentioned as output, and also followed by all the other inputs. Okay, now our design code for the gate level our design code for the AND gate and gate level model is ready. Okay, now we need to verify this particular design, whether this particular design is correct or not. Okay, we need to verify it. For that, we are going to write the test bench. Okay, For that we are going to write the test bench, and we are going to apply test cases to this particular design. Okay, to create the test bench for this particular design module, we need to write the test bench in the test bench, which is left side portion. We need to write the test bench in this area. Okay, so let me zoom it. To write the test bench, we are going to write the test bench of Verilog in between module and end module. So I am going to take module and then end module. Okay, and after module you need to give the module name. In this case I am going to use the module name as underget TB. Okay, and you should open parenthesis and then close parenthesis and then put the semicolon. Okay, you shouldn't mention any port list uh, in this parenthesis. Why? Because in the case of test bench we are not going to have the inputs and outputs. We are going to have the test cases only. Okay, now the second step what you guys need to do is, okay, you need to list the test cases. Okay, input test cases and output test cases. Okay, how you should uh, how you should mention those test cases means, I will tell you a simple trick, you just follow it. Okay, see, the inputs in design code will become reg data type in the inputs in design code will become reg data type in test bench. Okay, what are the inputs in the design code? Those are A and B, right? So we are going to consider them as reg A comma B. You shouldn't take like this, input reg A comma B. No. Why? Because we are not going to have inputs and outputs in the case of TB. We are going to have only we are going to have only we are going to have only test cases, right? So the inputs in design module will become uh, reg data types in the test bench. Okay, whereas the output in design module is going to become as wide data type in the wide data type in the wide data type in the test bench. Okay, what is the output? In this case we are going to have output as y, right? Now the second step is also became. Okay, now for which particular design we are going to apply the test cases? Okay, we are going to create the test bench. Okay, what is the purpose of creating the test bench? We need to apply the test cases to the design module, right? So that we need to call this particular or use this particular module in this test bench. How we are going to use this particular module in the test bench means, here is the concept that we are going to learn, that is module instantiation. Okay, we need to instantiate this particular design code module in the test bench, and we need to apply the test cases, and we need to verify the functional correctness of this particular design code. For that, how we are going to instantiate this particular and get design module in the TB means, you need to instantiate this particular module with the help of the module name. What is the module name of the design code that we have written is and underscore gate, right? So just write the module name and underscore gate, and then you need to give the instance name. Okay, we need to give the instance name. I am going to assume it as a naught. Okay, instance name is nothing but we are going to give that particular AND gate as a naught. Okay, we are going to call that particular AND gate as a naught. After that, you need to open the parenthesis and then close it and then semicolon. Okay, now in this you need to give some of the parameters. What are the parameters that you should give in this particular parenthesis means, see, in the port list of the design code, okay, we have declared initially inputs and then output, right? In the same order you should mention test cases. Okay, you should mention test cases. Okay, like this, a comma b comma y, that's it. Okay, in the same order you should mention. Okay, see, in the port list first you have mentioned input a and then b and then output y. In the same order you need to mention like this, a comma b comma y. If in the port list if you have mentioned output first and then later inputs, then you need to mention output first and then later inputs only. In the same order you need to mention. Okay, or else there is also another way to mention. That thing I am going to discuss in another video. Okay, don't worry. Next, the third step is also completed. Now what we need to do is, we need to apply the input test cases, right? We need to apply the input test cases for our design, right? so that you need to give some values to this particular you need to assign the values to the inputs, right? Okay, so we need to apply the test cases, right? So we are going to have total two inputs. How many combinations of input are possible means total four number of combinations are possible. Those are 2 power 2, that is equal to 4, right? So for that we need to use the initial block in this particular test bench. Initial, begin and then end. Begin and end are similar to the flower braces in C programming. Okay, begin and end are similar to the flower braces in the C programming. Okay, so you need to apply the inputs, right? So for that, let us use in the previous class also I have manually assigned the values, right? So now what I am going to do is I am going to take an integer. Okay, I am going to take the integer I. Now let me use the for loop. Okay, I am going to use the for. Okay, I am going to initialize the I variable, which is a iterator, okay, with 0, and then I less than or equal to 3. Okay, I less than or equal to 3 semicolon, I equal to I plus 1. Okay, I am going to update this particular variable I by 1 for every clock cycle. Begin and then end. Okay, I told you, right? Begin and end are working as flower bases in are similar to the flower bases in the C program. Okay, in this, now what we are going to take, we are going to take the concatenation operator. Concatenation a comma b, a comma b. Okay, a comma b, and then close it, equal to simply I. Okay, simply I semicolon, and we are going to provide some delay. I am going to provide some 10 nanoseconds of delay. That's it. Okay, now we have completed everything. So let me finish. Okay, let me finish. No, you shouldn't use finish in the for loop. Okay, let me come out from the for loop and then give some delay, that is 30 nanoseconds of delay, and then dollar finish. Dollar finish is used to stop the simulation of your program. Okay, next, now we have applied the test cases. Okay, so what is the concatenation operator means? For example, if the a equal to 0 and b is equal to 0, then concatenation of a comma b will represent single value that is equal to 0 0. Okay, for example, a is equal to 0 and b is equal to 0, a is equal to 0, b is equal to 1, then the concatenation of a comma b will represent 0 1. Okay, it is the value 1, right? It is the value 1 in decimal format. Okay, for example, a is equal to 1 and then b is equal to 1, then the concatenation of a comma b will become 1 1, and it will represent the single value, that is 3. Okay, like this the concatenation will work. Okay, initially I am going to initialize the I with 0, right? So that now in place of I we are going to replace the value with 0, right? I with 0, right? So whenever I becomes 0, then a comma b will a and b will also becomes 0, right? Okay, and after first iteration, it is going to increment by 1. Now the I value will become 1, right? So in place of I we are going to replace I with 1, right? So what happens is, now concatenation of a comma b is equal to 1. It means b value will be 1 and a value will be 0. Okay, now for the third case, I value will be 2 and I value will be 2, right? Now what happens is 1 0. 2 means in binary it is equivalent to 1 0. Now b value will be 0 and a value will be 1. Okay, for the last case, I value will be 3. I value will be 3 means in the binary it is going to represent as 1 1. So both the values of a and b are 1. Okay, a and b will be considered as 1, and you need to notice a delay in this case also. Okay, in this case you need to notice a delay. By default for loop is executed at 0 nanoseconds of point of time, but I have mentioned 10 nanoseconds of delay in this case. It means for each test case you just wait for 10 nanoseconds of time and then perform increment operation of the I, and then again loop again check the condition for the condition of the for loop. Okay, it means initially I equal 0, right? I equal 0, and we are going to take a equal to 0 and b is equal to 0 as per this particular line. Now we are going to wait 10 nanoseconds of point of time, and then again after it is going to update the I value, and it is going to run the for loop. Again it is going to assign the respect to a and b values with respect to the I variable, and then it is going to again wait for 10 nanoseconds of time. Okay, by default for loop will execute with 0 nanoseconds point of time, but we have specified the slash hash 10, right? So it is going to wait 10 nanoseconds point of time for each iteration of the for loop. That's the point of this particular 10 nanoseconds. Okay, after I equal to 4 this condition will be false, right? After I equal to 4 this condition will be false. The for loop will get will not execute, and it is going to come out of the, okay, we are going to come out from the for loop, right? After I have specified the 30 nanoseconds, it means wait till 30 nanoseconds point of time. Okay, I have given some additional delay. Wait till 30 nanoseconds point of time and then stop the simulation. I hope you guys understood what I am told you. Okay, now what we have done is we have applied the test cases, right? Now we have to see the output in terms of console, TCL console. For that we are going to have two options. One is to use the dollar display, another is you can use the dollar monitor. In the previous class I have discussed you with the guys, I have discussed you with the dollar monitor, right? The difference between dollar monitor and dollar display is dollar display will get printed only one time. Dollar display will get printed only one time based on the previous statement that you have written, whereas the dollar monitor will print number of times based on the change in your input. Based on change in your input, the dollar monitor will print several number of times. If your input changes n number of times, then dollar monitor will get printed n number of times. If your input changes n number of times but dollar display will print only one time, that too uh, that too which is related, the printing statement will be related to the previous statement which is written before the dollar display. Okay, so I have discussed about the dollar monitor. Now I am going to discuss about dollar display. Okay, but I have told you, right, here we are going to have total 4 combinations of inputs. For that we need to write 4 dollar display statements. No, we shouldn't write 4 dollar display statements. Instead of that we can write in this place. In this place we can write the dollar display. In the for loop itself we can able to write the dollar display. Okay, time, let us print the time. Time is equal to percentage 0t, which is a format specifier to print the time, and then a is equal to percentage 0t and 0b. I am going to print the a in binary, and b is equal to percentage 0b, and then finally output y is equal to percentage 0b. I am going to give the parameters. Dollar time is used to print the current simulation time, and then a, and then b followed by y. Okay, this is how we have written the dollar display statement in the for loop itself. This dollar display statement is get printed based on this statement which is written previous to it or before it. Okay, Based on this particular statement, it is going to print the dollar display. Okay, but we have written only one time, right? For all the cases, 4 cases, we need to write the 4 times, right? No, in the for loop we have written, right? So it is going to iterate for four number of times, right? So that no, we shouldn't need to write the four number of times. Okay, so we have written. Okay, now everything is good. Now we are going to get the console output with the help of this particular dollar display statement. Now how to get the waveform? For that, what you guys need to do is you just take another initial block, and then you need to use dump wares. Okay, initial begin. Let me correct it. Now till now what we have done is we have created the test cases, and also we have written the display statement to get the output in the console. Now what we are going to do is we need to get the output in the form of waveform as well. For that you need to include other two lines as well. Let me include them as well. So these are the two lines that you need to use to get the output in the form of waveform. Okay, now we have completed our TB, and also we have completed our design code. Okay, you don't worry about TB. Okay, you just learn about TB. Okay, for one particular code you just learn about the TB. You always focus on design code in the case while you are going to learn about the Verilog. While you are going to learn about the system Verilog, you are going to focus on the test bench. Okay, so now we have written our code. How we are going to execute the sorry, yeah, how we are going to execute this particular design code and check the functional correctness of our design code means we should run it, right? For that you need to go to the tools and simulator section and select the tool which is first one. Okay, after that you just save the code by clicking the save option above. Okay, and then run it. Now now we are going to see the output in the something is happened. Okay, it is going to show x. Okay, see, we are going to see the output in the console window, right? It is going to show x 0 0 0. It means in the TB we are going to have some problem. See, so let me specify some this delay. You take it, okay, and then put it above. You remove the delay and put it over here. Let us see what happens. Okay, you remove the delay and then put it over here. Save it. So I told you, right, for loop will execute by default at 0 nanoseconds of point of time. It means it is not going to take any time, but we have specified the delay, right? So I have specified the delay at the bottom. Now I have changed it to the top. Let us see whether it is going to change, or again we are going to get an error or not. I think no, we are going to get same thing, right? So what happened, let me see it. So let me remove this error, this time delay, and put it down. Okay, put it down over here only. Let me mention 0 nanoseconds of point out. Okay, we are getting some errors. Output is not getting. What happened? Let me see it. Okay, just a second. I have seen it. Okay, let me discuss with you. Okay, don't worry. So you remove it, and then I am going to remove this delay and going to place it in between display statement and then the above statement. Okay, let me save the code. Okay, I have seen Google it. Okay, sometimes we need to use chat GPT, but every time we are going to use chat GPT, that's not the correct case. Okay, See, now we have got the output, right? See, now we have got the output. We can see this is the operation of the AND gate. You can see it. Okay, whenever both the inputs are 1 1, and we are going to get the output as 1. For all other case, we are going to output as 0. Okay, so let me use non-blocking. Okay, let me use non-blocking and remove this particular statement and then use it down over here. Okay, let me use it. So again run it. Just a second. Let us see now whether we are going to get the output. No, we are not getting the output, right? So that just change as per previous. Okay, now let me run again. Now we can see we are going to get the output. Okay, so now we have seen the output in the console window, right? Now let us see the output in the waveform. For that, what you guys need to do is we have added the dump file and then dump wares. Two statements we have added. Now you need to click open EPWave after run. In the tools and simulator section, open EPWave after run and then save the code and then again rerun it. Now automatically the waveform will be opened. Okay. Now you can see the output. Okay, you can see the output. Let me delete variable I. Okay, or else yeah, let me delete it. Initially at 0 nanoseconds point of time, we have applied a equal to 0 and b equal to 0, and we are going to observe the output as y equal to 0. After 10 nanoseconds point of time, that is at 10 nanoseconds point of time instant, we have changed our inputs from a is equal to 0 to a is equal to 0 and then b is equal to 0 to b is equal to 1, and we are going to observe the output as y equal to 0. After 10 nanoseconds point of time, from 10 nanoseconds point of time instant, that is 20 nanoseconds point of time instant, we have changed our inputs from a equal to 0 to b, a is equal to 1, and b is equal to 1 to b is equal to 0, and we are going to observe the output as y equal to 0. Okay, after 10 nanoseconds point of time, from 20 nanoseconds point of time instant, that is 30 nanoseconds point of time, we have changed our inputs from a is equal to 1 to a is equal to 1 and b is equal to 0 to b is equal to 1. Okay, we are going to observe the output as y equal to 0, y equal to 1. Only for the case of a is equal to 1 and b is equal to 1, we are going to see the output as y is equal to 1. Okay, after some delay, 30 nanoseconds point of time, we are going to end the simulation. Okay, so this is the output, and we have verified. Okay, I have I have also told you how to verify this particular waveform. So you just observe my wordings, then only you can able to understand what I am going to tell you. Okay, so this is how we are going to verify our waveform. Okay, so finally we can able to say that our design code is functionally correct. Okay, in the next classes we are going to discuss about the same AND gate in all other models, all other levels of abstractions. So stay tuned. Thank you.